Good day, everyone. Welcome to Senior High School 2 Mathematics. Today, we're going to proceed with Chapter 2, which is all about measures of central tendency. So, we are going to learn the three measures of central tendency that are commonly used to describe the average value of a set of data. So, these are the mode, mean, and median. So when we say mode, it is the most commonly occurring value. And when we say mean, it is calculated by dividing the sum of the values by the number of values. And when we say median, it is the value in the middle of an ordered set of data. So we use an average to summarize the values in a set of data. As a representative value, it should be fairly central to and typical of the values that it represents. Let's have here a teacher recorded the scores of our students in a math quiz. So we have here the 18, 10, 7, 15, 13, 12, 8, 18, 20, 12, and 18. Okay, so the first thing that we're going to do is to check if this data are in the increasing order. So if it is a no, then we need to make it in the increasing order. So we have now the 7, 8, 10, 12, 12, 13, 15, 18, 18, 18, 20. So the reason why we are doing this is for us to easily identify the mode, the mean, and the median. Okay? So there is one number that keeps on appearing. So this one is unimodal. It is a set of data with only one mode. And our mean here, we're just going to add all of them and we got 151. And we have 11 scores here. So 151 divided by 11, that is approximately 13.7. And for the median, that means it's the middle. So since this one is the total of 11, so that means the sixth value is the median. Okay, so that is 13. So the teacher sees that the average performance is around 14, but the most common score was 18. Okay, so let's have another example. The number of goals scored by a football team in 8 matches. We have 0, 1, 2, 2, 3, 4, 5, 5. So since 2 and 5 keeps on appearing twice, then we can say that the modes are 2 and 5. And it is called bimodal because we have two modes. And our mean here, we just need to add them. So that is total of 22. We divide it by 8 scores. So 22 divided by 8, that would be 2.75. And for our median, since this one is 8 scores, that means 2 and 3 will be added. And we divide it by 2, we get 2.5. So the average goal scored by a football team in 8 matches is around 3, but the most common score was 2 and 5. Next, the scores of 9 students in quiz and science up to 10. So we have here the data. And as what we can see, this is not yet in the increasing order. So we're going to make it as 1. So we have now 3, 4, 4, 5, 5, 6, 6, 7, 8. So since 4, 5, and 6 keeps on appearing twice, that means our modes would be 4, 5, and 6. So this is called multimodal since we have more than 2 modes. And for our mean, we just need to add them and divide them with the total number of students. So we have 48 divided by 9, that would be approximately 5.3. And for the median, since we have 9 students, so we can easily see the median. So it is in the 5th place. So that is 5. And the average scores of 9 students in quiz and science is around 14, but the most common score was 4, 5, and 6. Okay, so let's have the mode and the modal class. A set of data may have more than one mode or no mode at all. So the following table shows the scores on 25 rolls of die, where 2 is the mode because it has the highest frequency. So in a set of group data in which raw values cannot be seen, we can find the modal class, which is the class with the highest frequency density. So we need to remember that in histograms, the modal class has the greatest column height. So if there is no modal class, then all classes have the same frequency density. So we need to remember that always. To further understand what I mean, let's have here example number 1. Find the modal class of the 270 pencil lengths given in the nearest centimeter in the following table. So we have here the length x as cm and number of pencils as the frequency. So 4 to 7 that would be 100, 8 to 10 that would be 90, and 11. Okay, here, so class boundaries, class widths, and frequency density calculations are shown in the table. So let us remember that class boundary is equal to class limit plus minus gap divided by 2. So since the gap between 7 and 8 is 1, we divide it by 2 and subtract it from 4. That gives us 3.5. And we also add it to 7, that gives us 7.5. So although the histogram is not needed to answer this question, but we still have here the histogram. So it is useful to see that in this case, the modal class is the one with the tallest column and the greatest frequency density, even though it has the lowest frequency. So we can see here that it is between 10.5 to 12.5. Let's have example number 2. Two classes of data have interval widths in the ratio 3:2. Given that there is no modal class and the frequency of the first class is 48, find the frequency of the second class. So no modal class means that the frequency densities of the two classes are equal. So class frequencies are in the same ratio as interval widths. So let x be the frequency of the second class. So 48 is to x is equal to 3 is to 2. So we can have here x divided by 48 is equal to 2 divided by 3. So we can multiply both sides by 48. So that gives us x is equal to 96. Or we can have x divided by 2 is equal to 48 divided by 3. Then multiply both sides by 2. Then we can also have x is equal to 96.3. Or we can also have the power of means and the power of extremes. So we have x times 3 is equal to 48 times 2. So that is 3x divided by 3 is equal to 96 divided by 3. So that still gives us x is equal to 96 divided by 3. So x would be equal to 32. So alternatively, frequencies are proportional to interval widths. So in this special case where all classes have equal widths, frequency densities are proportional to frequencies. So the modal class is the class with the highest frequency. So in this case, the first class is the modal class. Let's have example number 3. Four classes of continuous data are recorded as 2 to 6, 7 to 13, 14 to 18, and 19 to 28. So the class 2 to 6 has frequency of 60 and there is no modal class. So we're going to find the total frequency of all the classes. So in order to do this, we need to complete the table, right? So no modal class, that means we have the same frequency densities for all intervals, right? So in a no modal class type of problem, you didn't need to get the class boundaries because you'd use boundaries if you were asked to estimate the actual mode value. So here, remember that in our previous lesson in histograms, I presented this formula to you, right? So we're going to use this one to complete the table and to find the total frequency of all classes. So 60 divided by 4, that would be 15. That means all the frequency density of all the class interval would be 15. And 15 times the width, which is 6, that is equal to 90. And next, 15 times 4, that is equal to 60. And 15 times the width, which is 9, is equal to 135. So since we are asked to find the total frequency of all the classes, we just need to get the sum of all the frequency. So 60 plus 90 plus 60 plus 135, that would be equal to 345. Okay, so kindly prepare your pens and paper. So it's your turn to answer some of the problems. For number 1, find the modal class for 200 distance measurements. So we are given the table here. So you're going to use this one to answer the number 1, okay? And for the number 2, given the histogram, what is the modal class and why? Okay, I think it's time for us to check our answers. And for the number 1, we are asked to identify the modal class. So now this is our answer. So our width here from 0.5 to 4.5, that would be 4. So next is 5 and 6. So 80 divided by 4, that would be 20. 56 divided by 5, that would be 11.2. And 64 divided by 6, that would be 10.67. And as what I said earlier in the discussion, the modal class has the highest frequency density. So here, as what we can see, the highest frequency density is the class interval, which is x is greater than or equal to 4.5 but less than 9.5. So this is our modal class. So here in the number 2, we're going to identify the modal class using the histogram. So as what I said earlier, the modal class in the histogram is the one with the highest frequency density and the one who is the tallest. So here we can see that the modal class is the one with the highest frequency density, which is the 40 to 50 kilogram interval. So let us remember that frequency density shows how concentrated the data values are in that interval. So that is my reason and the why. Okay, so that ends our discussion for the mode and the modal class.